Hello again. In this video, I would like to provide you with a tutorial on a high-level programming language that is called R. Why do we teach this high-level programming language R in this class? Because first reason, R is a programming language which has too many built-in functions related to statistical studies. So it is practically one of the best high-level programming languages to practice the statistical applications which you are going to learn in IE 222 course and IE 224 courses. So what you are going to learn in probability and statistics for industrial engineers can be applied, implemented in this software. And secondly, the second reason why we are teaching R free. It's an open source programming language, and it also provides an interface where you can practice your applications. So unlikely to other high-level programming languages such as MATLAB, you do not have to pay anything to use R, and you can in fact implement complex codes or algorithms as well without paying extra. So these are the reasons why we are teaching R in this course. So at first, before going through, I would like to show you how you can download R. So to the Google, please write R simply. Okay. When you write R, you will see a link in the first place, which is the R project for statistical computing here. If you click on that, you will see here download link, CRAN, and when you click on that, you are just going to choose a mirror to download your software. And here, when you click on that, you will see three links. If you are a Windows user, you can download R for Windows. Or if you are a Mac user, if you are using a Mac operating system, then you can follow this link. Now, for Windows users, we are click on that, and when you click on base, you will be directed to the download link, download R402. This is the latest version of R, and you can download it from here. Then you can follow the installation steps and install it on your computer. As you have seen, we have downloaded it, and let's just assume that we have installed it. Then to start menu, you can just write R, and the first thing that is going to come around is the shortcut of R interface. And when you click on that, you are going to see this interface where we have a console and a working space. And right now you can see it a little blurry maybe, so I'm just going to arrange or interface options, and I will increase the font size to 14. I think that is going to make it much better observable. Okay, so in this console you can write your comments and you can implement an algorithm and run it. But the best way to do that is to do it with a script file. Now, if you click on file here, and if you choose to open a new script, okay, a new script, then you are just going to get an empty page, empty text file here. You can write down your codes here one by one. Then, let me practice it. So let's just say I'm going to variable x that is going to be equal to 5, and then I am going to create another variable y, and that is going to be equal to 10. Now I'm just going to calculate x plus y, and I'm going to assign that calculation to variable z. Then finally I would like to see the result of this command, print me z. What you are going to do to run this sequence of commands is to select all of them, either with your mouse, or simply you can press Ctrl A in PC, okay? Control A to select all of them. Then after doing that, you can just right click on that and you can say, run the sequence of commands. Or you can use this shortcut as well. So as you have selected everything with A, then you can press Control R to run everything. So let me do that. Control A, then Control R, and then everything will be run here, and Z as a result will be printed, and you will see the result is 15. So this was a very, very simple example where we can use a script file to write down all of our comments and run them all together in a single shot. Okay, so always choose to work within the scripts, and you can also save your script files from here. So you can choose to save your script file at any location, okay, at any location, and then you can find it again, the script file, and run it again. Now, in this introduction course where we teach R, I have already prepared a script file, which I'm going to open now, and I will teach you a few things related to R programming, which are very basic and also very useful in most statistical applications. This is just going to be an introduction. In the future weeks, we are just going to learn many other applications related to probability theory and statistics as well. So I'm just going to choose file, and I will say open script, not a new script, but open script. So I'm going to find my file here. So I have R tutorial, and I need to choose all files to see my script file because I have saved it in a TXT format, not with an R extension. I'm just going to choose to see all files. Now I have a R tutorial script file here, which is also available for you in the Black environment. I'm going to open it. Now you see we have a sequence of comments already saved here. We are going to run them one by one and learn about each of them. Okay, so see this sign here with a less than sign, then we have a line here, is an assignment operator. So what I have done here with x being equal to 3 is basically assigning with a 3 value, but this assignment also works in R. So you can simply write x, then you can write down a less sign, then a line, and this left arrow assigns the value that you have written here to x. Okay, so you don't have to put any blank space between the variables and the assignment operator. This is unnecessary, but I have done it in my applications for you to see better. Okay, this is an unnecessary operation. In fact, this is an assignment operator that assigns the value of 3 to variable x. Okay, so let's see here. We have assigned x the value of 3. Let's see x. I write x and I press enter. Then I can see the value of x. Now, the next thing, the next command line says the fourth index of x is going to be equal to 7.5. Okay, so if you write down a square bracket, and inside it, if you write an index, then the fourth index here of variable x is going to be assigned with 7.5. If I print x again here, I write x and press enter, you'll see the first element of x is 3, still 3, and the fourth index becomes 7.5. Because we have not assigned anything to the second and the third indices, they are not available. So you see, actually x here becomes an array of size 4. a vector of size 4, the first index and the fourth index of this vector is already assigned with values of 3 and 7.5, and the other indices are not available at the moment. So anything you write down in R, so let's do it again. So I assign the value of 3 to x now, and if I want to print x, I'm just going to see 3. So what I have created is a vector of size 1. A vector, x is a vector of size 1, and it's assigned the value of 3. Now, if I do that, the fourth index of x is going to be assigned with 7.5, then the size of this vector becomes 4, and the first and the fourth indices are going to be observable, while the others are going to be not available. Okay, so anything that I have created as a variable is basically assumed as a vector. Now, let's create a vector of sequential integers. So I have just selected this line and run it. So it says assign x a vector of integers from 1 to 8. So when you write a colon sign between 1 and 8, this means we are basically counting all integers starting from the first integer to the last integer. So x becomes a vector of consecutive integers starting from 1 and finishing at 8. And it is going to have the size 8. Okay, so it is going to have 8 elements. Now this is x. If I do the same operation like this, then y is going to become a vector of integers from integer 15 to integer 11. Okay, of course, because 15 is larger than 11, we are going to see these integers in a decreasing order. So all the integers from 15 to 11 are written in this vector. So x is a vector of integers from 1 to 8, and it has size 8, and y is a vector of integers from 15 to 11, and it has size 5. Okay, so we have created two vectors here. Now I am going to run down this. I will say that y is equal to x plus 3. Now remember, x was this vector. X was integers from 1 to 8, a vector of size 8, and I am adding 3 to this vector. So when you sum a vector up with a scalar, then every element of this vector is going to be summed up with that value, right? So y is going to become 3 added to each element of x, starting from 4 up to 11. Okay, all integers from 4 up to 11. Now I'm going to create a vector of integers from 1 to 8 and assign it as x, and I'm going to create another vector y of integers from 1 to 4, and it is going to be assigned as y. So let's see x and y. So x has the size 8 and y has the size 4. Okay, y is a shorter vector. What happens if I sum these two vectors up? Okay, because their sizes do not match. However, we are going to see a result in any way. So let's see what happens. Now you see in the result, the first element 2 is the sum of the first indices of x and y. The second element 4 is the sum of the second indices 2 and 2. The third index is the sum of the third indices in x and y, 3 plus 3. And here the fourth index is 4 plus 4. So what happens to the fifth index? Is it going to be 5 plus 0? Actually, no. Okay. Actually, the shorter vector is going to be repeated again and again until it reaches the size of the longer vector. So basically, y, the vector y, which has size 4, is going to be added in its tail until it reaches to the size of x. So 5 is basically going to be summed up with the first index again. 6 is going to be summed up with 2. 7 is going to be summed up with 3. And 8 is going to be summed up with 4. Now, you see 8 plus 4 is equal to 12, and we exactly see that situation. Okay, so if you want to sum up two vectors, the size of which do not match, in that case, R repeats the shorter vector and adds this vector into its tail until the length of the shorter vector becomes equal to the length of the longer vector. Okay. So what happens if, so you see we have a complete repetition here. So when you sum up x and y here, because y is of the half of the size x of x, so we have a complete repetition here. But what if the size of x is non-divisible by the size of y? Okay, so in that case, if you run this x plus y command again we will have a repetition. Okay, so let me see x and y. So 1 plus 1 is equal to 2, 2 plus 2 is equal to 4, 3 plus 3 is equal to 6. 4 is going to be summed up with the first element 1 again. 5 is be summed up with 2, 6 is going to be summed up with 3. So you are going to get 5, 7, and 9. Then 7 is going to be summed up with 1, and 8 is going to be summed up with 2. Okay, and you are also going to get a warning message where it is stating that the vector has a size which is non-divisible by the size of the shorter vector. Okay, so the length of the longer vector is not a multiple of the length of the shorter vector. You get this warning, but still the shorter vector is going to be repeated again and again, and until it becomes of the size of the longer vector. So this is a practical thing, and we are going to use that in many practices. Now, you see we have created many vectors which consist of consecutive integers. But how about I want to create an arbitrary vector? So see here, I'm just going to create a vector of 6 numbers, 4, 8, 15, 16, 23, and 42. So what I'm going to do is I'm just going to use the command C. C here stands for combine. So basically, combine commands combines everything in parentheses and creates a vector out of those components. Okay, so it combines these 6 values and creates a vector of size 6. So C stands for combine. I can also create another vector with combine command or C command, and Y is going to be a vector of size 4, 104, 208, 220, and 222. Okay, so we have x and y. X is a vector of size 6 of arbitrary numbers, and y is a vector of size 4. Now, I can also combine two vectors. So if I say z is another vector, by combining x and y, then you will see z is going to be a vector of 10 elements. So there will be 10 elements in this vector. This is going to be a combination of the first vector, and the second vector will be added into the tail of the first vector. Okay, so this is how we can create arbitrary vectors. We can also combine vectors. Now, what is the length of z? Okay, so I see many values in the vector z, but sometimes I may wonder how many elements I have in the vector z. So what I'm going to do is I'm just going to write length of z. So the command length gives me the size of z, and obviously you can easily count the number of elements in this vector. It is 10. So I can get the length of the vector with the simple command length of. So what does this command do? Z is equal to rev z. So rev here stands for revert operation, revert. Now you see z was a vector arbitrary integer values from 4 to 222. Okay, now I just want to revert this vector and assign the reversed version on itself. Okay, so if I just click on Z and press enter, you will see Z is reverted now. starting from the last element, previous the last element becomes the first element, and previous the first element becomes the last element. It is in the reversed order. So rev stands for revert. Now I'm going to create another vector with these comments, which is the repeat comment. So it says x is a repetition of value 5 and 10 times. Okay, so rep means repeat. Repeat 5 10 times. So what I'm going to see if I print x, I will have a vector of size 10, which consists of values of 5 only. So it is a repetition of value 5 10 times. So I can use this comment in different manner, and it is very important for us to learn how we can use the repeat comment. So let's just create a vector of y, which is a combination of 3, 5, and 7 values. And you see y is a vector of 3 elements, the elements of which are respectively 3, 5, and 7. And I'm just going to run this comment. So see z is a repetition of vector y 4 times. So what is going to happen? This time, we are not just repeating a single value such as 5, we are repeating a vector of size 3 4 times. So what I'm going to see in z is the repetition of y vector 4 times. Therefore, the length of z, the length of z vector is going to be equal to 12. So basically, y vector is repeated 4 times. Now, how about this comment? So it says repeat y with a count argument. That is a vector that consists of values of 2, 3, and 5. So in the count argument, in the number of repetitions, this time we do not have a single value. So we understand that this is a repetition of 5 10 times. This is a repetition of y vector 4 times, but this is a repetition of y vector with another vector. There is a count vector here. So it says y is a vector size 3 and the count vector is of size 3. So what is going to happen is this. The first element of y will be repeated twice. The second element of y, 5, will be repeated 3 times. And the last element of y, which is 7, will be repeated 5 times. So this is exactly what you are going to see. So the total number of elements in the vector is going to be 10 because the count vector sums up to 10. The first element of y will be repeated with 2. The second element will be repeated 3 times, and the third element will be repeated 5 times. So this is how we use the repeat argument. And there is another argument which can help us to create sequential vectors. Okay, now we already learned how to create a consecutive integer vector. Remember, if you want to create a vector of consecutive integers from 5 to 20, for example, you can simply write that comment and press enter. Then you get the vector of integers from 5 to 20. But what if I want to create a sequence, okay, with equal distances between consecutive elements, but this time it is not going to be an integer vector? So I can use this sequence comment. So SEQ stands for sequence. And it says, create a sequence start from 2 and ending at 3. And the length of this sequence is going to be 21. So length point out being equal to 21 means the sequence that I'm going to create is going to have 21 elements. So let's see. As you can see, it starts at 2, it ends at 3, and you see we have 0.05 length distances between the consecutive elements, because if you want to create a sequence of 21 elements from 2 to 3, then the distance between the consecutive elements is going to be equal to 1 over 20, or in other words, 0.05. Okay, so we have created this array. Now, there is 1 here and there is 16 here. Maybe you have been curious about this from the beginning. So what does these ones mean? What do these ones mean in the beginning of each output? So in this longer output, you see we have 1 here and we have 16 here. Now, remember, x is a vector that has the length 21. Okay. Now, when the output is of a very long size, maybe I may be interested in which index I am seeing in the next line, in the beginning of the next line. So you see, this is my first index, 2 is my first index in the output vector, in x vector, and 2.75 is the 16th index, okay? In fact, if I down this window and print x again, you will see my first index is 2, my 11th index is 2.50, and my 21st index is 3. Basically, the square brackets in front of the values in front of each line in the output shows me which index I'm seeing in the beginning of that row. Okay, now you see if I print x again, I will see all vector, the whole vector in a single line. Okay. Now I'm going back to my original size of my dot. Okay. Now you see I have created a sequence starting from integer 2 up to integer 3, and the length of this sequence is going to be 21. Because I have defined my length carefully, the distance between the consecutive elements has been automatically 0.05. Now, what if I want to create a sequence with the step size? Okay, again, I would like to create a sequence starting from 2 and ending at 3, but this time, instead of giving the length of the sequence, I'm just going to give the step size. So starting from 2, I am going to move to 3 by increasing the values with 0.05 at each time, and then I will finalize when I reach at 3. So here you see, again, x is the same vector. I start from 2, my step size is 0.05, so at next index, I'm increasing my previous value with 0.05 and creating this sequence, and I am ending exactly at 3. I stop exactly at 3. Now, if you check the length of this new x vector, you will see that it is equal to 21. Okay, so at this point, I'm just going to stop recording and I'm going to continue at this topic in the next video.